Hello everyone, so this is a short introduction to using the Data Visualiser application that you'll be using for completing Practical 10. So first of all, to be able to run the application, you'll be doing that with the main file. So you'll see when you open up the Practical that in the top left here you should see the src directory below the folder you've opened it from. And then inside of that src directory, there are a number of packages. So the only ones you'll be using as part of this practical will be the searching algorithms package, the sorting algorithms package, and the main.java. So this is with all of the files that you will be creating during the practical. It will start you with only a couple of these, but it will be adding those as you go through it. So when you run the program, you can either do it with the run up here, or if this isn't available to you, you can use the run over next to the main in the main file. So I'll just let this launch. So when you launch the program, you'll see something similar to what you can see on screen at the moment. You have, first of all, in the top section here, we can see the numbers that are making up the data set that we're performing sorts on, or we can also search. We have information here in the middle which shows a temporary value. So when you're sorting, this will be the place where values are temporarily placed and sort of then taken out from again once you're performing a swap operation. Then in the middle here, we can see there's select a sort/search algorithm. So this will change based on whatever the current sequence of the algorithm is that's happening. So if you're sorting, it will show swaps and comparisons as a count. And if you're searching, it will show the steps of that search. You'll see at the bottom here we have a graph. So as part of this graph, you can see that it's a histogram, and this is representing visually a visual representation of what it shows at the top. And so it just lets you see graphically what those numbers mean. So first of all, you can change the way this looks. So you can see down the bottom here under graph type, you can change to a line plot, a dot plot, a histogram and line plot, or a dot and line plot. So let's change it back to histogram for now, but you can change that to any graph type you would like to see. The other options we have here on the right hand side, so going from the top, you'll see we have a delay. So this delay lets you change the amount of time between each step of your algorithm. And there are a number of controls. So the controls that we have here allow us to play and pause the current algorithm. We have a step through. This allows you to step through the algorithm one step at a time. We have a fast forward that allows us to skip basically to the end of the algorithm. And then we have a stop. So you would use a stop if you have perhaps an infinite loop and you need to terminate your code right away. So the next section here, we have the ability to create a data set with a particular size and a particular set of data. So you'll basically, as part of the prac, it only asks you to use a data set size of 10, but it can go anything from 10 to 100 in increments of 10. So you also then have, based on the size, you can then choose a different type of data to fill it with. So at the moment it defaults to random. So if I click fill, it will fill to different amounts of data. So I'll just put it back to the 10 again. So with the random, it will just select randomly. With sorted, it will go low to high with a sorted set of numbers. With a sorted reverse, it will do the same, but you'll have high to low. And then for custom, if we were to do that and click fill data, we will get a dialog where we can enter in a series of numbers. So like if I do just a sequence of numbers, and then you can see it fills all of those numbers in based on what I entered. So let's go back to a random set of data again. Now you'll see that we also have a reset data. So this reset data button allows you to revert back to the last data order that you had the last time you pressed fill data. So we'll come back to that in a moment once I've demonstrated using the sort algorithms. So if I use the sort algorithms button, we can then sort the data from left to right. So you can change the direction of that. So we'll talk about that in a moment, but first, just if I click sort, you'll see as we're going through, the cyan color is indicating that there's a comparison happening, and the yellow is indicating that there's a swap happening. So every comparison has a pair of elements that are being highlighted as being compared as a less than operation. And then the yellow is indicating that there's an assignment happening, swapping a pair of elements, which involves going from, say, one element copied into the temp, then the element that was originally there is copied over by the other element, and then the temp is copied back into the other element. So we'll talk about that in a moment when we get more to seeing an example with the original bubble sort code you're given. So in terms of being able to select different algorithms, you'll have this drop down. So this drop down will correspond to all of the algorithms that you find under your package that you've created. So you should only create algorithms under this package that are sort algorithms. So we'll talk about what that means in a moment. But essentially, initially you will begin with just a bubble sort and a slow bubble sort. So the code for the bubble sort is incomplete because you will need to make it faster, and the slow bubble sort is doing more than it needs to. So when we have the sort low to high, that means that it will have the lowest value on the left and the highest value on the right. But if I was to, for example, sort high to low, I will just speed this up. You can see it sorts the opposite direction. So it's automatically changing. There's no change in the way the algorithm works. It's automatically handled using a compare function that we're asking to use as part of the practical. So I'll go through in a moment, show an example of each of the algorithms. So we have, first of all, the bubble sort. So the bubble sort, if I just reset data, so you can see it's gone back to what it was the last time I clicked fill data. So if we just have this sort, you'll see that it's moving through left to right, and it's comparing all of the elements. And you can see that it doesn't actually go all the way to the end after the first time it's gone through. It's going one less every time. And so this is what we're wanting you to do when you're trying to implement the first task, to be able to change it so it does this. Because originally, if we reset and use the slow, you'll see that it's going to go through the whole way first time, then it will go through the whole way the second time, and then the whole way another time, and it repeats the whole way through every single time, which results in a lot of unnecessary comparisons. And this also becomes a bigger issue with the more data you have. So you can see that that took quite a lot of comparisons compared to before. So we'll look at then what the selection sort looks like. So selection sort basically goes one element at a time, and then it finds the minimum value and then swaps those elements until you sort of get the minimum of each position from that point onward into the position. Then insertion sort, so I'll just reset again. Got insertion sort, and so insertion sort, it will find values and it will shuffle everything up and then insert the element as necessary. So you'll see there, it's making a series of swaps as it moves all of the elements up. All right, so now we have some sorted data. We can sort of look at what the search algorithms does. So as part of this, you'll initially just have linear search. So if I click search, you will see there's a dialog that appears, and inside of this you can type in a number. So if we search first of all for something that is in the data set, let's just search for 84. So you can see it goes through from left to right, just searching every single element to check if that element is equal to whatever that value is. And you can see it found it at 84. So if we were to search then for something that is not there, say 105, then we should see that it just goes through every element and then tells us it wasn't found. And you can see that while searching, it's showing the target value over here in the middle, and then it tells us that it was not found. So the other algorithm that it's asking you to create is the binary search algorithm. So as part of the binary search algorithm, you're essentially going and sort of narrowing in on where the target might be. So if we do the same thing again, first of all with the 84, so you can see there's a low and a high bounds, and it's checking, so then it moves into this section, and then it finds immediately on the second step that the target 84 was found. So if we do another one where we do 82, it'll add another step as well. So we'll just do 82. So you can see again it knows that it needs to be in the upper half, and then it needs to check a bit lower, and then it finds the target after a couple more steps as it sort of jumps around between the different values. So if we were to search for something that doesn't exist inside of here, let's just search for the 105. You'll see that initially it tries to search in the middle. It knows that it needs to search toward the end, and then it tries to search even further toward the end, and then finally it searches the last element, and of course it's not that element, and so it knows that it's outside the bounds of the array where that element would be located. So once we know that we've sort of performed a sort or a search, you'll find that clicking the View History button will bring up this dialog. So you can see inside of this dialog, we can actually see all of the steps that were performed as part of those searches. It shows us not only that information, but it also shows us the data we searched. It shows other things like the sort of whether it was found or not. It also tells us the number of comparisons that happened. But that is more important, for example, for the sorts. So you can see that for each of the sorts we've performed, it tells us the swaps and the comparisons. And so we can also click this Generate Report, and it will tell us information about what we did. So you can see that for this data set we just used, it has been sorted from low to high. We searched for 82, and that's told us how many comparisons it took with how many steps. And then we did it also with 84 twice, and so you can see the comparison between those two. And then it's also done the same for searching for 105. So you won't need to use the generate report for the practical, but it's interesting to know that it's there. Alright, so let's just take a brief look at some of the other things inside of the program. If you do not, first of all, want to have the larger view of the program, you can make it smaller. So in the main file, we have this main method that contains this call to launch with all algorithms. You can just change this to true, and if I run this again, you'll find that it is now a slightly smaller window. So now we have this smaller window. So if you're running on a lower resolution, I would recommend you do this, but if you're able to use the full size with false, you can just leave this unchanged. So with the default code, you'll start first of all with this bubble sort slow. So this won't be the file you're editing. in BubbleSort Slow, you'll be making those changes in the BubbleSort.java file. But in this BubbleSort Slow, you can see what's actually happening. So initially we have a while loop, and so it's a while there are still swaps that are happening. So while there are still swaps that happen sometime within this loop, it will continue to loop every single time, and it'll just keep bubbling the elements up. So initially it assumes that at the beginning of the loop that there was no swap, and then from that point onward, we're looping through for every element inside of our group of elements. So you'll see that we have this data elements object. This is essentially an array that contains all of the elements inside of our data set. And then we're using this compare function. So the compare function is comparing the element at index I plus 1 and I, and it's telling us whether or not they're less than, the I plus 1 value is less than I. And so it's looking at the values of those elements. So this compare function is special because if we had the sort low to high ticked, it will do a less than comparison. But if we had high to low ticked, it's going to do a greater than comparison. So by calling this compare function, we're essentially making it so it can sort either direction without having to change any of our code. You'll then see that we have this swap function call. So we have that if the element that is next after this element is less than the current element, we're going to perform a swap on those two. So essentially here we're saying to perform a series of steps. So if we go and look at this, so Control B on Windows will take us to the function. You can see here that we have a sequence of assignments that are occurring. So when you're doing the insertion sort, you will be using assign manually in a similar sort of way. But essentially, we're grabbing the reference to the temporary element. So remember, that's the one that's in the center middle of the screen. And so that is allowing us to store temporarily the value that's in the first element referenced by our swap. Then we're taking the index B value and copying that value into whatever over the top of whatever was stored in index A. Then we're overriding whatever was index B with the value we stored in the temporary value. So this is just a regular swap like you would do otherwise. The important part about this assign function, though, is it's sort of making it easier for you to not have to worry about the data elements themselves. It's just swapping the values for you, and it's also doing the coloring. So this is how it is actually coloring and causing the delay to be able to show the animation. So if we go back to the function, you can see that whenever we've had a swap happen, we're then saying that we essentially that there was a swap by making it true. So every time this loops and there's still a true at the end of it, it's going to continue this outer loop. Eventually though, once everything gets into a position where it can no longer be changed, this line here will not happen, and because of the swap equals false assumed at the beginning of the loop, it will then go back to exiting the loop eventually. So the other thing we'll just look at briefly is the linear search. So the linear search, you won't be writing the linear search, but you will be writing the binary search. So the important part here is that we have a couple of extra things. So one thing I didn't talk about with the extending classes. So if we look back into the BubbleSort Slow just quickly, you'll see that we have extends sort algorithm. So inside of your sorting algorithms package, you only want classes that extend sort algorithm. To be able to extend sort algorithm, you will need to import this core application.star, and you will also need to add in this as a constructor, where you have a Data Visualiser application main element that is being passed as a parameter, and you'll need to have a call to super where it passes both a string. This string is what shows up in the drop down when you're running the application as a string, and it also just passes on the reference to main. It also requires you have this perform algorithm. So both searching and sorting will require this perform algorithm method. So in terms of the linear search, you can see that for searching, we actually extend search algorithm instead. So this search algorithm class allows us to be able to perform some extra things that are relevant only to searching instead of sorting. So in this case, we again have that our constructor is passing a data visualizer application. This is essentially just a reference to our application, allows us to be able to load the classes in easily and just link them in with everything dynamically. In this case, we're passing in a string that just says linear search, and we're passing that reference to main. We're also setting a sleep multiplier here. So because searching is so much slower, it's so much faster in terms of what we're going to be able to see as the steps happen, we actually want to slow it down by a factor of say 10 or 15 times to be able to see the steps happen. Otherwise it'll happen blazingly fast and we'll have the operation over before we even see what's happened. So by doing this by default, it means that for the linear search, when we have 100 ms selected as the time delay on the application by default, it's actually saying that each step of the search is going to be 1 second. In the the binary search, you will be instead using 15 because there's less steps again, and so that will just slow it down even more. So as part of the writing search algorithms, there are a couple of things that are slightly different to how you would write for the sort algorithms. You have a found index variable, that's where you should store the result of your search, and you also have that you need to update the status label manually. So you can see I've got this dataset.set status label, and then we've got this get search summary string. So this get search summary string, this is taking the result of whatever you've stored inside of found index, and it is generating a string based on that. So if we just look at what that method has inside of it, you can see that we generate a result string that starts out saying target, whatever the value was that we were searching for, and we're checking then what that is for the index that was found at. So if it was at -1, we just say we didn't find it, or otherwise we say it was found at whatever the index was, and then just repeating that the value at that index was the result we were expecting. And then we just return that string, which is then printed to the screen. So then in terms of our code, you'll see that we call linear search. So you'll be doing the same thing in here for your binary search, but instead you would be, of course, writing binary search here. And then your method down here will be binary search, and you'll follow the steps to be able to create your code. As part of this, you can see that we have a loop for our linear search. Remember, this is going to be searching for every element inside of the list of elements, just from beginning to end, until it either finds a match or it finds nothing at the very end. So we just have a loop for every element by saying the data elements.length. To be able to highlight the comparisons that are happening, we're using this highlight and log method. You'll be using a very similar one for the binary search, which will actually take 3 parameters instead, with the low, high, and mid point. But because we only have one index we're comparing against the target, in this case, we are just comparing the value for I. And so we're just highlighting position I. You can see we compare by getting the value directly from the element, and we're comparing it to the target value. So you'll need to use a similar thing when you're comparing against values for the binary search. So if we do find a match, we're essentially just returning the position where we found that match. And if, for example, we don't get to find by the end of the loop, so if we didn't find the value while searching through every single element, we just return -1. And that tells us that we did not find anything inside of it. So hopefully this introduction helps with the practical as you're beginning to try and work through it. And good luck.